Okay, welcome to the third homework video from chapter 2. In this one, I'm going to do problem 50. And so what we have is some firm, Expedition Outfitters. They're going to produce a Mount Everest parka and a Rocky Mountain parka. And so I think, if you read through the problem, this is kind of similar to problem 28. The first thing you want to do, I guess I'll write this over here, is convert, this is what I did, convert to minutes. Or if you'd like, you could have converted to hours, right? Now the reason for that is because they say the manufacturing plant has 120 hours of cutting time and 120 hours of sewing time. But then, for each parka, like the Mount Everest parka requires 30 minutes of cutting time and 45 minutes of sewing time. Now, you could have converted everything into hours, which means that, if you keep it in hours, then for the Mount parka, it would be 0.5 of cutting time, right, and 0.75 of sewing time. So it doesn't matter which way you go. I just did it with minutes. So I guess what I'll do is I'll insert a row, and so this would be my cutting time. Let's see. Yeah, cutting time, and then sewing. Now, since I'm going to keep everything in minutes, so my Mount Everest, 30, Rocky Mountain, Rocky Mountain, 20 minutes of cutting, right, and then for sewing, Mount Everest is 45 minutes of sewing, and then the other one is 15 minutes, right? And then the idea is my plant capacity, so these are going to be less than or equal to, right? And if I convert these all to minutes, so then I've got 120 hours times 60 minutes. That's per hour, so I've got 7,200 minutes. And then, oh, wait a minute. Both are 120, so great. Just copy this down. All right, well, there are two of your constraints. Now I've got one more, and I'm going to come back to that constraint in just a minute. But now I need to do the profit per unit, and that was pretty simple. I hope you would agree, right? They tell you that the price is $250 for the Mount Everest, $200 for the Rocky Mountain, but labor and material costs $150 for the Mount Everest, and then $50 for the Rocky Mountain. Right, so for the Mount Everest, I'm going to get 250 minus the 150. There's my profit per unit for that guy. And then for the Rocky Mountain, I'm going to get 200 minus 50, and voila, there's going to be my profit per unit for the Rocky Mountain parka. Now, there is one more constraint, and I guess I'll call this... Okay, so here's the constraint. Because management believes that the Mount Everest parka is a unique coat that will enhance the image of the firm, they specified that at least 20% of the total production must consist of this model, right? So I'll just put capacity, or no, it's not really capacity. How about just production? Okay. So here's the idea. I'm going to get my pen out again because I want to do some writing. Okay, so they said, right, that the Mount Everest, right, must be greater than or equal to 20% of my total production, right? So, what's my total production? This is the key. My total production is Mount Everest plus Rocky Mountain, right? I hope that makes sense to everybody. That's how I would interpret this constraint, right? Must be at least 20%. So my total production is ME plus RM. So now I'm just going to solve this. ME greater than or equal, to 0.2 ME plus 0.2 RM. And then I'm going to move everything over to this side So I'm going to get 0.8 Mount Everest minus 0.2 Rocky Mountain has to be greater than or equal to 0. That is how I would have written my production constraint. Okay, so what I would have done here in this production constraint, I got to get rid of this. I would have put 0.8, negative 0.2, and then this would have been greater than or equal to 0. And then, of course, I still have my non-negativity constraints. Okay? So let me just pause here. I hope that this makes sense to everybody. That just comes from the problem, right? The Mount Everest parka has to be at least 20% of total production. So just write it out and then solve. All right, so with all that said, so what am I going to do? I'm going to maximize. Oops. I'm going to I don't know why I'm doing that. I really don't. I'm going to maximize 100 times Mount Everest plus 150 times Rocky Mountain, subject to, let's see, let me just go up a wee bit here. Okay, go down one. Sorry, I'm trying to keep everything on one screen. So subject to 30 Mount Everest, of course it disappeared anyways, plus 20 Rocky Mountain, and that had to be less than or equal, I think it was 7,200. Yep. And then I have 40 and 15. No, 45 and 15. 45 Mount Everest plus 15 Rocky Mountain less than or equal to 7,200. And then I have that last one, 0.8 minus 0.2. 0.8 Mount Everest minus 0.2 Rocky Mountain. That has to be greater than or equal to 0. Perfect. All right, there we go. So here is my problem. So now I'm ready to solve this. So I'll put it over here. So here is Mount Everest. Oops, here's Rocky Mountain. Right, here are my parameters, choice variables, objective function. Okay, I don't want that big. There we go. All right, so 100, 150. Right, placeholders, 1 and 1. And then the objective function is always the sum product. I know you're going to get tired of me saying that, but I got to. So highlight my parameters. Highlight the choice variables. Hit OK. And then I got my constraints. Constraint 1. Constraint 3. Okay, so the parameters for my constraints, 30, 20, 45, 15, 0.8. Now, negative 0.2, less than, greater than, less than equal to, less than equal to, greater than equal to, and then 7,200, 7,200, and 0. And there you go. Well, let me just make this a little bigger. All right, there we go. And then, of course, I've got this one, right? What are my constraints given the value of my choice variables? So sum product once again. Choice variables, parameters, and as always, anchor the choice variables. All right. There we go. So here, let me see if I can get everything on one page for you. I don't know if this helps, but I always like seeing everything on one page so I don't have to keep scrolling back and forth. Yeah, perfect. All right, well, there you go. So now we are set and ready to do this. Okay, so let's go into data. Let's go into solver. All right, so I want to maximize that objective function by changing these cells subject to these two parameters have to be less than or equal to those two numbers. And this has to be greater than or equal to that. I've got this box checked. Simplex LP, hit solve, voila. Here is, okay, that's all right. There's my, ooh. Well, what the heck, comma format these. Okay. And let me comma format all these as well. Okay, there you go. All right, so there you go. So we are going to produce basically, 65 Mount Everest parkas, 262 Rocky Mountain parkas, and we're going to maximize our profit at 45,818. And there you go, solution. So there is your answer to problem 50. All right, well, that's it for this video. In the next video, I will do problem 51. Take care.